Good afternoon everyone. In last lecture or study we have seen the circular motion, different aspects related with circular motion, that is angular displacement, angular velocity, angular acceleration, with three kinematical equations in terms of angular physical quantities, that is angular displacement theta, angular velocity omega 1, omega 2, angular acceleration alpha. Now we have to study another part, some important concepts related with circular motion, and then the beginning of your chapter related to 12th standard syllabus, that is centripetal force and centrifugal force, and then applications of circular motion. So last, that is relation between linear angular velocity, acceleration and time, we have seen there are few another relations. There is linear velocity of any object, v velocity is given by r omega, where r is radius, omega is angular velocity. Acceleration, it is tangential acceleration. This tangential acceleration is given by a equal to r into alpha, where alpha is angular acceleration. So this is relation between linear velocity, angular velocity. This is relation between linear acceleration, angular acceleration. There is again one term which derive, one concept which we derived in last standard, that is 11th standard, that is centripetal acceleration, EC equal to v square upon r, or it can be written as again r omega square. So velocity upon radius, this is called as centripetal acceleration, which is acting along the center and along the radius and towards the center. So it is called as centripetal acceleration. In terms of linear velocity, it is given by v square by r. In terms of angular velocity, it is given by r omega square. This is centripetal acceleration. Again, small but basic concept, that is time period. Capital T equal to, it is 2 pi by omega, and again one term frequency, it is equal to 1 by capital T is equal to omega by 2 pi. So these are again most important concepts related with circular motion, which we have studied in last standard, that is 11th class. Now we have to study the concepts related with 12th standard syllabus, that is centripetal and centrifugal force. So as we have seen the expression for the centripetal acceleration. So what is centripetal force and centrifugal force? Centripetal force. So name itself suggests it is centripetal, means it is not like gravitational, nuclear or electrostatic. It is just center seeking. While a particle is performing circular motion, its acceleration is acting along the radius and towards the center. If the object has certain mass m, it has acceleration a, then we have capital M is equal to mass into acceleration. So centripetal force can be written as F equal to m into AC, centripetal acceleration. As we study the expression for centripetal acceleration in last standard, that is, but is AC equal to v square upon r, or r omega square. So centripetal force can be written as F equal to m into v square upon r, or F is equal to m r omega square. In circular motion, this is circular motion. This force is acting along the radius and towards the center. This is object of mass m moving in such direction, in anti-clockwise direction, and the force acting on acceleration acting on this object is towards the center. It is called centripetal acceleration. So as the particle has certain mass, it possesses some force which is acting towards the center along the radius This acceleration is also called radial acceleration. Similarly, the force acting on the object of mass m performing circular motion which is along the radius and towards the center is also called as centripetal force. So the centripetal force is F equal to mv square upon r, or F equal to m r omega square in terms of angular velocity, in terms of linear velocity. So in vector form, as it is acting along the radius and towards the center, in vector form this force can be written as capital F is equal to, it is minus m into v square upon r into r0 cap. Do you know the name of this r0 cap? It is a unit vector. Its magnitude is 1, but it is always along another vector, which is radius vector. So the vector which is along another vector whose magnitude is equal to 1 is called as unit vector. So this minus sign shows that force and this radius vector or unit vector are in opposite direction. So radius vector which is away from the center, and this force is directed towards the center. So therefore it is called as centripetal force. Or also you can write in terms of angular velocity, vector F can be written as, it is directly minus m omega r in vector r, where r is radius vector and F is centripetal force. This minus sign shows that force and radius vector are in opposite direction. So this is centripetal force. While solving examples related with that objective type of examinations, many times there are relation based questions. We have to convert one quantity, given formula of one quantity, into another terms or another physical quantities. Here F is equal to force equal to mass into velocity into radius. Can we write this formula instead of mass, velocity, radius in another quantities? So that is a basic part which you must know. So let us consider here again, capital F is equal to m into v square upon r. We can write this formula in terms of kinetic energy. So F is equal to 1 by r into 1 by 2 into m into v square into 2. Got it? These 2 get cancelled, remaining part is again mv square upon r. What is this 1 by 2 mv square? Yes, it is kinetic energy. So we can write this force as 2 into kinetic energy divided by r. This is one form of this centripetal force. In another form we can write, we know we have small p is equal to m into v. What is p? It is linear momentum, product of mass and velocity. Can we write this formula in terms of p? So F can be written as m square into v square divided by m into r. One m get cancelled, it remains mv square upon r. What is this? This is m into v whole square divided by m into r. So we can write capital F equal to, it is p square by m into r. This is second relation in terms of linear momentum, mass and radius. From this relation also we can write formula for T, where T equal to m into r into f, square root of m r f, where m is mass, r is radius, f is centripetal force. Again one part, if you know the definition of angular momentum or the concept of angular momentum, which you have studied, I think you have studied in rotational dynamics, which is actually we have to study later on. So again this equation can be written in terms of that angular momentum also. So this is centripetal force which is acting along the radius towards the center. So it is called as centripetal. Can you give me the example of the centripetal force? This force is also called as a real force. What is real force? The force whose origin can be explained is called as a real force. So why the centripetal force is called real force? There are a number of examples in which the centripetal force exists. Do you know the law of gravitation given by Newton? Newton's law of gravitation states that force of attraction between any two bodies. Actually, that force between the planet and sun causes circular motion of the planet. A planet is revolving around the sun. In which orbit? Circular orbit. So circular motion of the object is due to that gravitational force. Means that gravitational force provides necessary centripetal force. That is why centripetal force is a real force. So in example number one for centripetal force, that every planet revolves around the earth, revolves around the sun in circular orbit under the action of gravitational force. In such motion, the required centripetal force for the circular motion is provided by the gravitational force of attraction. You know the second example, motion of electron around the nucleus. We know that in an atom, nucleus consists of protons and neutrons which are concentrated in a very small place called as nucleus. And around that nucleus there is a small space in which that electrons are revolving. Means motion of electron is circular. And as we know, circular motion requires centripetal force. So what is the concept, what is the term which provides centripetal force for the motion of electron? It is given by Coulomb in electrostatics. That force is called as electrostatic force between two charges. In atom there are two charges. One is on proton, which is positive. Second is on electron, which is negative. The negative and positive charges have attraction. So electron is revolving around the nucleus in circular orbit. The necessary centripetal force is provided by which one? Electrostatic force of attraction between positively charged nucleus and negatively charged electron. Therefore, such a force is also a real force. Means that centripetal force is provided by electrostatic force. In short, you can say that the reason or origin of centripetal force can be explained, and that is why it is called as a real force. Another example, just we can take example like this. This is a pendulum which is tied with the help of string. If I rotate this string with my hand, that motion of pendulum is a circular one. In this motion, I get some shock due to that heavy particle, light mass particle, and that tension in the string is provided by, it provides the necessary centripetal force for the circular motion of that object. You can tie a stone with the help of a string and revolve it like this. You will get some shock to your hand. That shock are due to the tension in the string, and the tension which is acting towards your hand acts at the center, so it provides centripetal force. So there are a number of examples in which we can find this centripetal force. So centripetal force is a real force. Again, we have to remember that. Again, it exists in inertial and non-inertial frame of reference. I will give you information about this inertial and non-inertial frame of reference later on. Next is centrifugal. It is again an important force, centrifugal force. Centrifugal force, centripetal force and centrifugal force. It is also present in circular motion, but it does not causes the circular motion. It is effect of circular motion. हा जो centripetal force असतो तो सर्क्युलर मोशन प्रोव्हाइड करत असतो, कारण असतो. सेंट्रिफ्युगल फोर्स हा सर्क्युलर मोशनचा परिणाम असतो. Centripetal force is the reason of circular motion, but centrifugal force is effect of circular motion. What is definition of the centrifugal force? As its name itself suggests, it is away from the center. Centripetal, it is towards the center. So the same magnitude is same, but just direction is different. So centrifugal force, the force acting on particle performing circular motion along the radius and away from the center, it is called centrifugal force. The magnitude formula is same, that is capital F is equal to m into v square upon r. Same object of mass m moving with velocity v along the circle of radius r, then it experiences a force which is called as centrifugal force, F equal to mv square upon r. In vector form, this can be written as capital F is equal to m into v square upon r into r0 cap, where r0 cap is unit vector along the direction of radius vector. It is directed away from the center, so centrifugal force is directed away from the center. Then what is difference between centripetal and centrifugal force? This centrifugal force is most important difference is centrifugal force cannot be explained, or its origin cannot be explained. That is why it is called as pseudo force. We cannot call this as imaginary. We can call this as non-real. Word is used in your book, that is non-real, or in another words we can see it as pseudo force. So pseudo थोड़ा खोटा, त्याला मराठी शब्द असतो छदमी, खोटा force. कसा? I will like to give one example how you can explain or you get the concept of centrifugal force, how it is called pseudo force. In case of a vehicle, suppose this is a vehicle, your classroom is total like just bus and I am a driver. The bus is moving along the curved road and finally it gets turned with certain speed along the curved road. What will happen? Yes, the passengers or you, all of you will be pushed in one direction. If we turn towards the right, what is the direction of your motion? Your motion will be outward, exactly opposite to that of turn. Why you get some push in outward direction? Can you explain the reason? That's why it is called as pseudo force. आपली जेव्हा बस ही अशी टर्न होते लेफ्ट साइडला, त्यावेळेस आपण मधले कुठे ढकलली जातो? राईट लेफ्ट साइडला ढकलली जातो. आपली बस जर राईट साइडला टर्न होत असेल, पुढच्या वेळेस आपण जर राईट साइडला टर्न केली तर आपण लेफ्ट साइडला जाऊ, अशा पद्धतीने. म्हणजे ज्या दिशेला बस टर्न होते त्याच्या अपोजिट डायरेक्शन आपण ढकलले जातो. आपल्याला कोणी रिकामे का ढकलायला? That force is called as pseudo force. It is centrifugal force. Look example like this. This is an object which is actually in vertical line, along a vertical line. If we try to revolve it like this, what happens here? It is moving away from its initial position. We are not giving any push or any pull or any force in another direction, but that object is moving away from its original position due to the pseudo force called as centrifugal force. This is centrifugal force. लहानपणी तुम्ही यात्रेत कधी गेलात, ते असं मेरी गो राउंड सारखं एक हे असतं लाईक दिस, त्याला अशी खुर्ची वगैरे असेल तुम्हाला पाहायला मिळेल. त्याच्यावर जर आपण बसलो आणि हे जर फिरायला लागलो, दुसऱ्या वेळेस हे असे बाहेर सरकते. कशामुळे सरकले बाहेर? ह्याला